All right, good afternoon, everyone. Thank you all so much for taking the time. We know this is a block packed with awesome talks, so we really appreciate you coming in. So as Haley said, my name's Ian Sotnick, and I'm joined by Jacob Wren, and it's really our pleasure to spend some time with you all today to discuss aligning the efforts of data science teams with the needs of the end users that they support. So at the very least, what I hope each of you walks away from this talk with is just with the seed of a question planted, specifically the question, to what extent am I mindful of the gap that exists between the deployment and the meaningful productionalization of machine learning? So we'll break today's talk into the following parts. First, I'll introduce what we've come to know as the last mile problem of machine learning productionization. Then I'll point to specific challenges that this problem poses for the machine learning lifecycle. The next part of the talk will focus on how we've seen this problem solved using intelligent applications. And finally, I'll turn it over to Jacob, who will demonstrate how Databricks, with just a little bit of help from AISquared, can be used to retrofit existing applications or web pages with artificial intelligence. So what is the last mile problem? Sometimes we find that data science teams can fall victim to tunnel visioning on pushing models to deployment, essentially treating deployment like it is the last step in the machine learning lifecycle. So while this absolutely maps to some KPIs for machine learning leadership, it also reflects a little bit of magical thinking, that just making a machine learning model accessible, quote unquote accessible, to end users via an API, it'll immediately be able to start providing some business or operational value. What we've experienced, however, and this is both professionally as data scientists as well as in talking with our customers and other industry leaders, is that this isn't a realistic approach to allowing people to derive real value from machine learning. And this is because this approach introduces both technical skill barriers and workflow efficiency frictions that can ultimately conspire to keep end users from adopting those machine learning models that organizations are spending tens to hundreds of thousands of dollars to train and deploy. So outputs from deployed models really do need to be conveyed to end users in ways that are accessible and useful, and doing so represents solving the last mile problem. So how does this problem come about? The first reason that we've arrived at is that the machine learning lifecycle is highly siloed, manual, and disjoint. The interaction between the people building and deploying the models and the end consumers of those models' outputs is frequently pretty minimal. And once a model is deployed, that's often the end of any engagement that did exist. And this is, of course, assuming that the model gets that far in the first place, which really isn't a foregone conclusion. Model deployment pipelines are tightly coupled with cloud service provider technology. And in the case of a lot of large enterprises, this is just slightly less convoluted than a bowl of spaghetti. In tightly controlled environments, for example, some federal agencies, deployment can be even less efficient, as access to these resources is tightly constrained for budgetary or security reasons, for example. For example, Jacob, who spent a few years as a data scientist in the public sector supporting analysts, frequently ran into problems where it would take upwards of a year sometimes to actually get access to the resources that he needed to deploy a model, even just to make it moderately accessible to end users. The siloed nature of the machine learning lifecycle also makes experimentation in production environments challenging. So in an ideal world, end users would have an open line of communication back to the data scientists who support them to assist in evaluating the performance of that model in real-world production use cases on real-world production data. At the same time, in this same ideal world, end users would be able to communicate back to the data science teams and data science leadership about the value and impact that that model is having, i.e., is this model providing inference that is aiding or, in some cases, not aiding so much the decision-making process, resulting in operational success or revenue. So the response that some organizations have had to the last mile problem is pretty at home in like a 2008-ish software engineering world, which is just build an app for it. And this approach really just relies on the creation of standalone machine learning embedded dashboards or bespoke applications that essentially just wrap a machine learning model or API with a nice fancy UI, which does nominally solve the problem of the technical skills gap required for users to access outputs from a model. Unfortunately, what this also means is that larger organizations with tens to hundreds of models in production end up with these large, unwieldy, and extremely expensive constellations of these one-off applications that end users then need to pick and choose how to incorporate back into their workflow. This approach also ignores the key point that end users, be they national security analysts or financial advisors, really do tend to rely on just a handful of core applications for the vast majority of their work. You know, the CRM tools, Dynamics, Salesforce, Splunk, et cetera. So functionally, what this approach is asking these end users to do is step from these core workflow applications to a standalone dashboard, and back to their core workflow, to standalone dashboard, and potentially repeat this process hundreds of times throughout the day. So in this paradigm, it's really no wonder that some organizations are finding that analysts are simply willing to throw away whatever additional value is provided from a machine learning model, because this is introducing those frictions that I spoke of previously. Essentially, this is making their workflow incredibly much less efficient. So on the face of it, what these end users are looking for is fairly straightforward. End users of machine learning models want models to yield actionable, relevant, and accurate insights. And they want these insights made available how, when, and where they can provide the most value. At the same time, by coupling these model outputs within the context of the rest of the operational workflow, an end user is also well positioned to properly assess both the accuracy and the value that that model is providing. So solving this last mile problem really demands intelligent applications. That is, embedding model outputs directly in the handful of applications that end users are already relying on as the backbone of their workflow. But how do you connect the model and the application? So as Jacob will show you, one approach to doing this is using AISquared's browser-based technology to surface model results in pre-existing web apps or web pages wherever they need to be to make an impact on improving decision-making. So without further ado, I'll turn it over to Jacob, who will demonstrate how to use a model created in Databricks to make a web page intelligent.
All right, thank you, Ian. So my name is Jacob Wren. I serve as CTO and Head of Research at AISquared. And what I'm really excited to show you today is how we are using AISquared's technology stack within existing development environments such as Databricks to enable intelligent applications. And the way we're doing that, so just as the machine learning process starts with good data, the machine learning integration process starts with a good model. And using AISquared's technology, we take that existing model, we compile that with some configuration information using the AISquared SDK, which is a Python SDK, which can be utilized in any Python environment. And what we do with that is we compile that into what we're calling a .air file. And what that file does is it enables the interaction of that model directly into the browser environment via the AISquared inference engine, which takes the place or takes the form of a browser extension. And what that does is it enables the immediate integration of that model into the browser environment to allow the end user to see the insights that that model can provide. So with that, what I'm going to do is I'm going to show an example of how you can use the AISquared technology stack to integrate a facial recognition model that classifies a individual's age based off of a photo of that individual. So here, right here, I'm sure everybody is very familiar with this interface right after the past couple of days. This is a Databricks notebook. And just as some background, what I'm going to be doing is I'm going to be using the UTK Face dataset, which is an openly available research dataset that contains information about, images of individuals and then a set of labels including their age. And what I'll be doing is I'll be building a classifier that identifies that person's age by decade and then integrating that within the browser environment. So first, you'll notice here my imports. You'll notice I import AISquared, which is our pip installable package. And then I'm also importing TensorFlow, and I'll be building this model within TensorFlow. So the reason I'm using TensorFlow here is we have native integration between TensorFlow and AISquared, which enables the model to actually be deployed directly to the browser without deployment to a third-party resource. We're also working on PyTorch integration as well as scikit-learn integration as well. I don't want to go into too much detail here, but I have the data already loaded to the Databricks file system. I set some parameters for how I'm going to be training the model, et cetera. Create a data generator for actually loading and training the data. And then down here is where I actually create the model. So for pre-processing steps, the model is going to take input shape of 256 by 256 pixels. And we're going to rescale each of those images by dividing each pixel value by 255, just to make the values of each pixel between 0 and 1. And then for training and image augmentation to help build a more robust model, I'm going to be performing some random horizontal flipping of the images, as well as random rotations. For the model itself, we're going to be using around 18 million parameter convolutional neural network, which is a fairly standard architecture with a couple of convolutional blocks fed into a fully connected network, which then outputs a quasi-probability distribution for that actual prediction. Now, what I want everybody to see here is that this process is the exact same process you'd go through if you were doing integration with AISquared versus not doing integration with AISquared. We do not change the training process. You build your model just as you normally would. So here I train the model, I evaluate it, I get its loss and its accuracy. I save the model in H5 format, which is the TensorFlow format for Keras models. And then, as I said before, the model is about 18 million parameters here. So that's great. So we have that model. So in that process that I showed you before, we need a model and we need configuration. So what we're doing here is we're going to actually create that .air file using the AISquared SDK. First, what we start with is what we're calling a label map. So this is a mapping from the actual predictions of the model itself to the human readable format that our analysts and our end users can actually understand. So instead of class 0, that means this person is identified as age 0 through 10, for example. Okay, so now that we're here, we need to configure the entire process from grabbing data within the browser, pushing it through the model, and getting predictions. So we first start by telling our extension what we need to harvest. We start with a harvesting object. And this is an image harvester. So we also have text harvesters, we have selection harvesters, which enable you to copy and paste things. But for this use case, we have an image harvester. Now, just as I pre-processed data going into the model before, now I need to pre-process data that's going into the model within the browser in the exact same way. So we instantiate what we call an image preprocessor, because we're pre-processing images. And we instantiate that with a few steps. So what do we need to go through, and what did we go through before? We're going to resize those images, just like we said, to 256 by 256. And then we're going to divide by 255 to get those values between 0 and 1. Okay, so now we have data, and we've pre-processed it. Now we need to put it through the model. That's where this step comes into play. And because I'm using a TensorFlow model, I can use this local model object, which says, I want to use this model locally within the browser. It doesn't need to be deployed to SageMaker, Azure ML, any of those third-party resources. We're going to actually use this model in the browser locally. I'm going to give it the save location of the model, so the file name, and then just tell it that it's a CV or computer vision model. So now we have predictions. We need to post-process to actually get that to human readable format. So I'm going to instantiate a multi-class classification object and give it that label map that we said before. So now we have predictions. We want to actually render them within the browser. So we're going to use the image rendering class. Now what this is going to do is for every image that's predicted on within the browser environment, we're going to put a border around that image. And we're also going to, in the bottom left corner, put what that prediction actually is. So I'm configuring this with a thickness of 2 for that border and a font size of 10 for the text itself. Now lastly, something Ian mentioned was the importance of feedback within the machine learning lifecycle. So when we actually use this model, we want to enable users to provide feedback on how that model is performing. Is it doing well? Is it not doing well? Should we just take it out of production entirely, maybe retrain? So I'm going to configure this multi-class feedback here, which enables the user to provide information via another widget. And I'm going to show how that works later. Okay, so I know that was a lot, but now we have model, we have configuration, and we're going to put that into the model configuration class. And that's what actually allows us to compile that down to an AIR file. So here is where I do that. I'm going to put all of those steps that I mentioned before, run the compile method, and that's it. So now, at this point, the model is saved in that .air format on our Databricks file system. Now, to show our integration even further with Databricks and other development environments, I'm going to be actually logging that model with MLFlow. So if you're familiar with MLFlow, I have an experiment running here where I log all of the parameters that I want to log for how to train the model, the metrics that of how that model actually performed on some test data, and I'm logging the model itself and that AIR file. So over here, I've run this before, and as you can see, I have this .air file. So what I'm going to do is I'm going to download this AIR file, and it's going to take a little bit of time, and in that time, I'm going to show you the actual extension within the browser. So the AISquared extension, the Community Edition, is available on the Chrome store, which is what you see here. And I'm going to install that extension, accept, and after a few seconds, we'll see that the extension is installed. Now this is really where the fun begins and where we actually get to see the results of that model working within the browser. So to actually show you what the interface with the extension looks like, you can see here, as I pull it up, we have all of the available models within the extension. Now, by default, we've provided you with a MobileNet model that was trained on ImageNet. But you can also see this Add New Model button. So what I'm going to do is I'm going to click that, and that's going to bring me to the extended view for the extension. And once again, I'm going to click Add New Model. You'll see I get this interface. I'm going to click. I'm going to find that AIR file that I just downloaded. I'm going to hit Enter and hit Submit. I see that it was successful. Now very quickly, I want to highlight how fast that was. No provisioning of additional resources, no deployment of servers, of containers, anything. The model is now usable by the end user within the browser environment. And instead of just telling you that, I want to show you. So what I'm going to do, since this model was trained off of headshots, I'm going to go to our company website, I'm going to find our team, I'm going to find all of our headshots. What I'm going to do is I'm going to use this model just by hitting play within the browser environment. So I pull up here, you'll see that model is now in the browser. I'm going to hit play. And it's going to take a few seconds because of this model is relatively large. But what you'll see is after a few seconds, we actually have the predictions rendered within the browser directly. Now, it's a little hard to see, right? This is great. It's a little hard to see. What if I want to change how that model is actually rendered within the browser on the fly? Let's say, I can see this border. It's blue. It's great. But I want to make it pop a little bit more. And like I said, the text here is a little small. So let me go ahead and show you how you can do that directly. So I'm going to go back to the view here. And as you can see, I can view this configuration. Click here. And this shows me all of those steps that I configured with my Python SDK in the browser and that I can edit. So if you remember, I'll be editing the rendering step. And like I said, I want to make this red now. And let me make the thickness of this, let me make it 4. And let me change that font size to 20 as well. Let me save. And we see that the update was successful. So if I go back to this web page, I'm going to hit play again. Again, wait a few seconds. I've done this enough, I know it takes about 6 to 7 seconds each time. And as you can see, now we have those predictions rendered within the browser yet again. Now this in and of itself is way different than integration is done for many organizations. But I wanted, and I promised I'd show you that feedback, right? So if you'll notice, there's this widget down here. And if I click on that widget, I can see all of the images that were predicted on. Now, if I show you all of these predictions, these three look all right. I'm going to go down here, and I know Lloyd. He's very young at heart, but he's not 0 to 10 years old. Similarly, I know being the director of engineering can be a stressful job, but I didn't really realize it aged Brian this much. So what I'm going to do is I'm going to show you how you can provide feedback within your workflow to that data scientist who's building that model. So for here, I'm Ben right here. This is the image. This is correct, so I'm going to provide positive feedback here. I'm going to say, yes, this is a correct prediction. Now similarly, I'm going to go down to Brian, and we can see here, I'm going to provide negative feedback and say no, and we get an additional little pop-up that says, well, what is the correct value? So with that, I'm going to submit that correct value, and that information is stored within the database within the laptop itself. So we can then download that information, we can collect that information, provide it back to the data scientists. And the beauty of what we're doing is we're collecting the data that was predicted on, as well as that feedback information as well. So we're harvesting data and labels to help us improve that model in the future. Now what I've shown you today is a little bit of a fun example of how we can use AISquared within the browser environment. For our customers, let me go back. For our customers, we've seen a variety of different use cases. So we've seen models that they want to integrate within the browser environment directly like this. We've seen deployed models that they want to utilize within the browser as well, across a variety of different tools, Dynamics CRM, for example, dashboards, et cetera. Wikipedia to help them with their research, different things like that. But with that, I'd like to thank everybody in attendance today, and I'd love to open up the floor for questions as well. Thank you.
I had a question for you right off the bat. What runtime were you using? Because it looked like I was looking at the timing on all the commands, and it looks like it was taking like 4 seconds. And
yeah, for Databricks, let me see what exactly I'm using. That's a great question.
And then does anybody else have a question while they're working on that one?
Let me see. There, if you could see that, that might tell you.
Okay, 10.4 machine learning runtime.
It's also a single node cluster as well, so it's not a multi-node.
Thanks, a great presentation. For when the deployment for prediction of this, are you using the local machine compute for the prediction itself?
I'm sorry, could you repeat that?
When you are calling the model and predicting the image classification here, are you using the local machine compute to do that?
Yes, yeah, so it's not deployed anywhere. So we're using TensorFlow.js on the back end. When we perform that compilation, we're actually converting the model to TensorFlow.js and using the laptop itself to perform that prediction.
Okay.
Thank you.
Okay, anybody else? Here you go.
Is there any kind of a sort of an API or an interface to, so say you have a custom web application and you've got this extension installed and you want to interact, say, with the results of the prediction and then do something with them in your own application? Anything like that? Yeah,
so the extension itself is kind of powered by our Air.js SDK. And what we do in the situations where customers want to utilize this kind of technology within an existing internal web application, we license out the SDK to them and then kind of show them how to use it, and you can use this kind of directly within that application. Great question.
I wanted to thank the speakers again for your presentation today, and make sure if you have an ability to get feedback through the app, just let them know about their talk. And thank you for your time.
Awesome. Thank you so much.
Thank you.